Welcome. In this lecture, we're going to talk about inverse functions. These only exist, I highlighted this by the title, that these only exist for bijective functions. So we're going to start out by supposing that, suppose that, so we have f from s to t, from s to t, is a bijective function. Okay. Then we're going to have that we have an inverse. So this is kind of definition. So f inverse, and this is going to be a function that's going to go from t to s. Okay. Is, I will box this. Okay, so this is and called f inverse. It's a name for it. Okay, so what is this? This is the function right, which, so it's defined by, what's going to be defined by is that how do I apply it to, so we know that its inputs are coming from t, so I have to figure out what the output is for an element of t, and what it's going to be is the unique element s. So this is the unique element s, in our set S, right, satisfying that when we go the other direction, so if we take f of s, we get out t. Okay, so it's kind of undoes it, goes the opposite direction. Okay, and so our hand waving way of saying this is that, so hand waving is that f inverse undoes whatever f did. Okay, but we can concretely say this hand waving thing, so let's go ahead and do that. So concretely, what do we have? Okay, so that was a hand waving explanation. Here's the concrete explanation, which is going to be, so the first one is going to be that if I take okay, so I'm going to put f inverse here, I'm going to put f there, so meaning that if first I apply f and then I apply f inverse to any element of, so if I'm applying f first, that means I'm starting with in s, so if I apply this, then I'm going to get s for all s and s, i.e. this is the identity function, so this composed with this is the identity function on S. And so what is that? This is the function, so I've got S is going to take, so this is going to be a function that's going to go from S to S. and it's just going to take everything precisely to itself. Okay, so it's S is always going to S. Okay, so that's what I mean by the identity function on S. Okay, so this is the first thing that has to be true, so 1. And the other thing is that if I go the other direction, where I'm first applying F inverse, and then I apply F. So now, because I'm applying F inverse first, I have to go, I'm applying this to an element T, but I'm going to get out T for all T and T. Okay, so i.e., when I compose in this way, which is actually to apply F inverse first, right? This is actually the identity function on T. The identity function on T. The identity function on T. So you could probably guess what the identity function on T does based on what the identity function on S does. So it's just going to be the function which is going to take everything in T to itself. So it goes from T to T, and what it does, so it takes every element in T to itself. Okay? So something to kind of observe here. I know these things are confusing to students. What is actually going on here? Okay? So we're actually going like broadly using all the colors, which is fantastic, except that, okay, so let's look at this function here. So F inverse composed with F, and what's going to happen with that. So we're going to start, so what does it actually look like? So we have S, and then we have T, and then we have S. And honestly, I sometimes draw these diagrams for myself because these things can get confusing. Like, so even in research mathematics, I sometimes draw these kinds of diagrams for myself to keep track of what's going on. Can you see that? Yeah. Okay, so we're going to take, so the first map, so F, right, F takes S to T, and then F inverse takes it back again. But this is actually going to work the opposite way too. So in this one here, what do I have? And then actually, and maybe I can emphasize this here, that what is the map that goes all the way like that is precisely this map. So that's a map that where I first apply, and it looks funny, right? Because I'm first applying F, and then I'm applying F inverse, and it looks like it's the opposite direction there, but it's not. It's just so that it's easier, like if I wanted to apply to F with this notation S, first I apply F, and then I apply F inverse. I can do a similar kind of thing here. So I have, I have my T, and my T, and my S is now in the middle, and my element T here and some little element S in here, and it's like first I've got F inverse going like this, and then I've got F coming after, right? And then the entire thing together, even though, again, it looks like I've made a mistake and written this in the wrong order, the way to not think that you've made a mistake is to think, well, first I apply F inverse to my S here, or to my T here, and then I apply my F. Think of the order that you would apply them in if something was over there. Okay, so this is kind of the picture that goes with those, and then we have an overall picture for the entire thing. So we have this S here, and I have this T here, and it's like I have these elements S1, S2, and S3, and then I have the elements F1, F2, F3, sorry, T1, T2, T3. Okay, and what happens, right? So if F is going to take S1 to S2 and S2 to T2, wait, S1 to T1, S2 to T2, wait, I want those all to go up. We got to have room to go down with the inverse, and S3 to T3, then our F inverse is going to take them back the other direction. So this is my F inverse. It's going to take me back the other direction, and undo what I just did, and bring me back home. Okay? So that's kind of how inverse functions work when you're kind of struggling to sort out what's going on. Sometimes actually it helps to just tie yourself to the formalism. I know that that's like the opposite of what we want to do sometimes, but actually sometimes when you just work with the formal definitions, it all just kind of falls into place, and otherwise sometimes you get your intuition messed up or something. But other times actually can really help to diagram it out. And so maybe try diagramming it out first and then see that you can do it formally. But this is what's going on with an inverse function. We only know they exist for bijective functions, and they undo whatever our original function did. But the other kind of hidden in here, new terminology is what we mean by identity functions. And our identity functions are just functions that take everything back to themselves. Okay, so I hope that was helpful and made some sense, and I will see you in the next lecture.